So in this video we're going to look at the product rule, but first of all we're going to start off with this question. So currently, before you know anything about product rule, how would we differentiate this? Okay, so we'd have y equals 3x plus 1 x squared plus 5, and what we do is expand the brackets. So y is equal to 3x cubed plus x squared plus 15x plus 5. Sorry, it's gone a bit blurry. And then we would differentiate this. Okay, so 3 times the 3 is 9x, take 1 from the power squared, plus 2x, take 1 from the power is just 1, plus 15. So that's okay currently, but if this question was slightly different and both of them were squared brackets, we'd then have to expand 4 sets of brackets, which in an exam isn't exactly what we want to do. Okay, it's going to take up quite a lot of our time, and that's definitely not something that we want to sit there doing. So product rule is definitely a lot quicker with some questions. So the product rule we can only use when we've got something that looks like y equals u times v. So that's when we use the product rule. Okay, you don't need to use it for when you've got something like 2 times x. Okay, but when you've got kind of something, two different things that contain x, maybe 2x times x plus 1 or x plus 1 to the power of 4, something like that. Okay, that's when you would kind of use that use product rule. So this is the product rule. So I suggest you write this down. So if y is, remember dot means times, if y equals u times v, then the differential of y is equal to u times dv dx plus v times du dx. So you don't need to write this down because I'm going to do a couple of formal examples in a second, but that question we've just looked at, if we were to use the product rule for this, so we've got y equals 3x plus 1 brackets x squared plus 5. Okay, if we were to use it for this, we've got u is the 3x plus 1, v equals x squared plus 5. The differential of u with respect to x is 3, and the differential of v with respect to x is 2x. So I've differentiated this to get 2x, differentiated this to get 3. So the product rule, dy dx, we use u dv dx plus v du dx, that's supposed to be a capital U, equals, so u is 3x plus 1, dv dx is 2x, add v is x squared plus 5, du dx is 3. Okay, so dy dx, 2x times 3x is 6x squared, 1 times 2x is 2x, add 3x squared, add 15. So we get 9x squared plus 2x plus 15, which is exactly the same as what we had up here when we expanded the brackets. Obviously, in this circumstance, this way is a little bit quicker, expanding the double brackets and then differentiating. Okay, but we're going to look at a question in a second where it kind of shows that it's definitely not the quickest way, and we need to know how to do product rule just in case questions like that do come up. So your first example is this one. So differentiate y equals x squared brackets 2x plus 3. Okay, so we know we've got y equals something times something else. They've both got x's in. So we know we've got something that looks like y equals u times v. Okay, so I'm going to say that my u is equal to x squared. My v is equal to 2x plus 3. Okay, I differentiate my u with respect to x. So du dx is equal to 2x. I differentiate my v with respect to x, so dv dx equals 2. Okay, and then I use chain rule, so dy dx. So that's my differential of the original question. Sorry, it's just gone a bit blurry. Wait for it to sort itself out. So the differential is u dv dx plus v du dx, which equals u is x squared, handling that, dv dx is 2 plus v is 2x plus 3, du dx is 2x. Okay, I then expand that. So 2x squared, 2x times 2x, so plus 4x squared, plus 3 times 2x is 6x. So when I simplify that, I get 6x squared plus 6x. Okay, so the next example is this one. So this is a question where you definitely wouldn't want to expand out your brackets, because that would take a lot of time out, and the A-level exam is already quite tight for time. So we want to differentiate y equals x take 2 all squared, brackets x plus 1 to the power of 3. So my u is x take 2 squared, and my v is x plus 1 cubed. Okay, so I'm going to differentiate them both. So differentiate u with respect to x. So I've got to use chain rule. So I get 2 lots of x take 2 to the power of 1, but I'm not going to write the 1. And then dv dx equals 3. Differential of x plus 1 is just 1, so 3x plus 1, take 1 from the power, is squared. Okay, then my whole differential, so dy dx is equal to u dv dx plus v du dx equals, that is a u. So u is x take 2 all squared, dv dx is 3x plus 1 all squared, plus v is x plus 1 all cubed, du dx is 2 lots of x take 2. Okay, so then obviously we can simplify this. So we get 3 lots of x take 2 all squared, x plus 1 squared, plus 2 lots of x take 2, x plus 1 all cubed. Okay, so I'm going to factorise this. I'm going to take out x take 2 and x plus 1 squared. So x take 2, because x take 2 is in both this term and this term, and then x plus 1 squared is in this term and this term, and I'm left with, in this term, 3 lots of x take 2, and in this term I'm left with 2 lots of x plus 1. Okay, I'm going to sort out this bracket. So x take 2, move it up, sorry, bracket x plus 1 all squared, 3 lots of x plus 2 lots of x is 5x, 3 lots of negative 2, add 2 lots of 1 is negative 4, and there is your answer. Okay, so we've used product rule because we've got something containing an x multiplied by something else containing an x, so a product.